Welcome to another session on operating system and Linux. This is session number 3 and I'm Manibhushan D'Souza. In today's session, we are going to talk about system components which are part of the operating system structure. We know that operating system is composed of many components. There are many things that makes up the operating system. Now, if you want to explore an operating system, we need to know the different parts of the operating system. So if you want to look at the operating system, you can view the operating system in different ways. There are generally 3 ways of looking at the operating system. First, by examining the services that the operating system provides. What do I mean by saying service is whether my operating system allows me to save my content, whether my operating system protects my data or my files, or whether my operating system does its work efficiently. So what are the services that the operating system provides? Using my operating system, is it possible for me to connect to an internet? So this is one service that the operating system provides. So if you look at the various services that are provided by the operating system, then we can learn more about the operating system. In the same way, we can look at the operating system by looking at the interface that it provides to the user and the programmers. So how do I interact with the operating system? By using my mouse, can I interact with my operating system, or do I have to type the commands, appropriate commands to interact with it, or can I use the touch interface to interact with it? So how do I write a program? How do I execute the program? These are all the interface that the operating system provides. So how do I interact with the operating system? That is what is the other way of looking at the system. The next one is to actually disassemble the operating system and look at the various components inside it. So you look at how the operating system works, which are the different parts within the operating system, and then learn about it. We are going to explore all of them one after the other. So first let's look at the system components. So these are the one way of looking at the operating system. So we are going to look at the various components which are present in the operating system. We know that operating system is a large and complex system. There are many components which are part of the operating system. In general, the operating system consists of following components. These 8 components are process management, memory management, file management, input-output system management, secondary storage management, networking, protection system, and command interpreter system. Let us look at an individual component one after the other. We are going to begin our journey with the process management. So what is a process? We must understand that thing first. So in order for us to understand the process management, we must have a clear understanding about what is a process. In your first year, you have written programs either using C or C++. So this program performs a lot of things. So what you do? You write a set of instructions one after the other. For example, you may write a program that adds 2 numbers. You might have written that program. You might have also written a program that can multiply 2 matrices. Or you might have written a program that will sort a set of numbers. Or maybe you have even written a program that allows you to quickly search for an element. These are all the programs that you have written or you have typed. Now what is this program? Program is set of instructions. So you write the set of instruction and save it onto the hard disk. If you just write and save it, nothing is going to happen. So then how do you make the things really work? You execute the program. So when you execute the program, every instruction that you have written, every command that you have written, that is going to be executed. In other words, the machine is going to carry out those actions that you have specified in the instructions. So in other words, the machine is going to perform those instructions or those actions that you have asked it to do so. So when your program is running, that is what you are generally saying, my program is running. So when your program is running, it is dynamic, it is active, it is doing some work. Whereas your program that you have written, the C or C++ program what you have written, is passive. It is not doing anything except that it is stored as a file inside your disk. Whereas when you execute the program, it becomes an active entity. It does something. So after one instruction, next instruction is executed automatically. So when this kind of action, or when this thing happens, when your program is getting executed, we don't call that as program anymore. Instead, we call that as a process. So what is a process? Process is a program in execution. So process is that state when your instructions are being carried out by your CPU. So when the CPU performs those instructions, or when your machine performs those actions that you have written, that time we call that as a process. So process is a program that is getting executed. Okay. Now execution of the process is generally sequential. What do I mean by saying that is CPU executes one instruction. So you have written the C program, you know very well, it starts from the main, then whatever variables that you have declared, it's going to do that. Then maybe you have written a printf statement, scanf statement, and so on and so forth. So the CPU or the central processing unit or the microprocessor takes one instruction at a time, and it's going to execute. So at most one instruction is executed at a time. Maybe you might have studied that things can be done in parallel. So that is the different thing. We will not go in that kind of complication. Now, a process is something that is performing some action. That means it's a work that is being carried out. Now, when we say you are carrying out a work, to carry out a work, you need some kind of resources. Something is required in order for you to carry out. What is that something? So in order for your instructions to be executed, you need some CPU time. So your process has to be executed by your microprocessor or CPU. Your program may require some data, or your instructions has to be read by the CPU. From where will it read it? It's going to read it from the memory. So some memory has to be allocated. So your program may read it from a file, or your program itself is loaded from a file. So it requires a file. Again, if you have written a scanf statement or printf statement, your program is going to make use of some devices. All these things that you are looking at, all of them are resources. They are the resources that are being used by your process. Okay. So who is going to provide those resources to your process? Naturally, this is done by the process management. So the work of the process management is to provide these resources to your process. When is it going to give? So it may give it when the program starts or when the process is created or when it is really required. When you say that I want to print, the operating system may provide you an access to the printer, otherwise it may not provide you that. Apart from this, your program may also require some initialization data or input output that is also given to your program by the operating system. So when we look at the process management, we have to look at the processes. Now we know that there is one process. So you are writing one program. There may be more than one program that is running at any instance of time. For example, you are running your program on Windows system. There is an antivirus software which is running. You may be playing a music in the background, or you may get connected to the internet and you may be chatting with someone. So there may be more than one process. So a system may consist of collection of process. Now, some of the processes are part of the operating system. So, operating system also requires some program, is it not? So, operating system is not something magic. It is a set of instruction that has to be carried out. Okay, so these are all system codes that gets executed behind the scene. At the same time, there are some processes that are started by you. Maybe the browser that you have started, maybe the word process that you have started, maybe the spreadsheet that you have started, or maybe the music application that you have started. All of them are user codes that you are being using. Okay. All of them are being executed concurrently. And so it is not that the operating system will say that, okay, I'm going to execute my system code and nobody else should work. It is not that case. Operating system will do its work, the antivirus will do its work, and your music player will do its work. All of them are doing their work one after the other. So they are all concurrently doing it. And who is going to handle these things? This is handled by the process management. So operating system is responsible for all these things. What are all these things that we are talking about? So in terms of process management, the operating system allows you to create a process, to start a process. So you have written a C program and you have compiled it, or C++ program, you have compiled it and linked it. So you have this machine instruction or binary instruction. This instruction has to be first loaded into the memory so that the CPU can execute those instructions. So who is going to load that into the memory is the process management, and that is what is called as creating. Creating means your program is already compiled, everything is there, it creates a process. It's going to say that one work has to be done. So it creates that work so that that work can be assigned to your CPU. Okay, when one work is completed, it's going to delete that work. Remember, very important thing, creating does not mean that you are going to compile your code. So you write your C program, so you write a set of instructions in a C program now, and then you compile it, or C++. This compilation process is not process management. That's a different thing. Once you compile it, you get the binary code. That binary code is loaded. During that time, process management will come into picture. When you are typing the program or when you are compiling the program, there may be errors. You know very well, when you try to compile the program, you get a compilation error, either syntax error or and so on and so forth. All of them are not handled by the process management. Remember that. That's a different thing, issue altogether. So our process management helps in creating a process, deleting a process, either the system process or the user process. If for some reason your process has to be suspended, it will suspend the process and resume it at appropriate time. Also, you may have one process and you may have the other process, and you want them to be synchronized. For example, from your Microsoft Word, you are printing your files. So either you want to print a document. So this is Microsoft Word, and there is this printer process that is controlling the printer. There must be synchronization between them. It is not that Microsoft Word will give entire files to the printer, and the printer will say that no, I can't handle this whole thing, you give me one line at a time. So then in that case it has to give one line, and once one line is printed, then the next line has to be given, and the next line has to be given, and so on and so forth. So that there is a synchronization between the two processes, and that is handled by the process management. Next one is the communication. As I have already told you, there are two processes are there. How can they synchronize? In order for them to synchronize, there must be a communication. If they are not communicating with each other, there is no way that they can synchronize it. So when one process wants to stop the other process, or when one process says you please slow down, I'm not able to follow up with you, then there must be a kind of communication between the two processes. Who is going to handle that thing? That is handled by the process management. And the last one is it may so happen that one process is waiting for the other process, the other process is waiting for some other process, and the other process may wait for the first process. So this first one is waiting for the second one, second one is waiting for the third one is waiting for the first one. So this is called as a deadlock. Everybody is waiting for the others. So you know very well, during the traffic jam, you want the vehicle which is in front of you to move. You will not move, but you want whoever is in front of you, they want. And what they are, person who is driving the vehicle in front of you, that person also want the somebody who is in front of him to move. So everybody wants the others to do something, but they are not ready to do anything. In that case, what happens is there is going to be a deadlock. When the deadlock happens, entire system will come to a standstill. So when such a situation arises, process management must know which process has to be slowed down, which process has to be terminated, which process has to be suspended. All these things are taken care by the process management. Now let's look at the second component, and the second component is the main memory management. So we know very well that what do I mean by saying main memory? Main memory is our RAM. Okay, so in the RAM, what you have, there are bytes, or you can also call as words. So there will be lot of bytes are there. You store the information in bytes, and every byte is addressable. Okay, has its own address. So 0, 1, 2, 3, 4, and so on and so forth. Okay, if at all you want a program to be get executed, it has to be first placed in the RAM. If the program is not there in the RAM, CPU will not be able to access its instruction nor the data. Okay, so the first thing that any program, if at all it wants to run, is it has to be first brought to the main memory. From the main memory, CPU will read the instruction, and the CPU may read and write the data. So depends on how the program works. Okay, so when you look at the computer, you want the computer to do many things at a time. So that means to say that many program has to be brought into the memory. Okay, so what the operating system or what the computer is going to do is, at any instance of time, it will not simply load one program and say that okay, this is one program is there, let it complete, I'm going to go for the other one. No, it's not going to do it. It's going to load many programs as much as it can. Okay, and it will ask the CPU, okay, take this program. And if the CPU is free, it will say okay, don't waste your time, take the other program. If the CPU is free again, it will take the other program, and so on. So in other words, to keep the to utilize the system or to utilize the CPU, to its best possible use, what the operating system will do is it will load many programs into the memory at the same time, and as and when it is required, it's going to give it to the system. Okay, so now the question comes is, you have a program here, and this program gets completed. Now then what? Which program has to be brought here? So where is the space? What will happen to this space or the bytes that are given to the program? All these things has to be controlled, and who is going to control that thing? That is controlled by the main memory management. So the operating system is responsible for the following activities in terms of memory management. First of all, it has to keep in track of which part of the memory is currently being used. So in the RAM, you have one part. So whether this part is used, if it is used, who is using it? Or who, when I say who, which program is using that particular memory. So if there is this part is being used, so which program is using this part of the memory? Okay, next one is which program has to be loaded, whether this program has to be loaded, whether the program P1 has to be loaded, or whether the program P2 has to be loaded, which program has to be loaded and where it has to be loaded. So that is also the other one. And you know very well, when the program you starts you give some memory, and after that the program may say that I want some extra memory. It is a usual case, is it not? So you may start with you may start your Internet Explorer or maybe Firefox or any other browser, and you may start to go to Gmail. After that you may go to YouTube. So how will you do that thing? You will start one tab, and after that you will start the second tab, and after that you may go to the third tab. All of them, all these tabs that you have started, all of them requires memory. So the operating system gave you this much of memory, and when you start the next tab, your program said I want some extra memory. After that again it says I want some extra memory. So who is going to allocate, or once you close the tab, deallocate, remove this? Who is going to do that thing? All these things are taken care by the main memory management. Next is the file management system. One of the very visible component of the operating system is the file management system. So there are those who are not very familiar with the operating system. They think that the operating system is only responsible for managing the files. So it only helps you to save the files and retrieve the files. That's the only thing they know. But they really don't know that apart from this handling of your data, that is the file, operating system is responsible for many other things. Okay, so now let's look at the one other very important component of the operating system, and that is the file management. You know very well, we can store the data. Now today we can store the data in many different forms. I can store it in the hard disk, I can store it in my pen drive, I can store it in my SD card, I can store it in my magnetic tape. I don't know whether you have seen those magnetic tapes, because your generation, I'm not very sure about that thing, but you can store it in the magnetic disk, or at least most of you have seen the CD-ROMs and DVDs, so you can store it in the DVD. Now remember, when the media changes, it is not the same way in which the data is stored. Now you know very well, CDs are optical devices. That means they read the data in optical form, whereas the tape or your hard disk stores the data in magnetic form. Okay, so you have the magnetic disk or magnetic tape. So this way in which it stores is very different. Okay, and how do I access that data is also very different. Now if you look at a disk, if you just look at the disk is storing in a circular format in the form of you might have studied about tracks and sectors and so on and so on. What about the tape? this tape is actually continuous media. How this is accessed, how the data is stored here and how the data is stored in this region, they are different. Okay, if you really want to know in depth, it's going to be a very terrible thing. So operating system abstract all those things. Okay, every media has its own characteristics. So how it is organized, how the data is stored, how it is retrieved, what is the way in which it has to be done, all these things are abstracted out, and the operating system will give you a simple way of accessing the devices. Now again, when you have your CD, you know very well, at least all of you have used, most of the devices still have the CD-ROMs, and there is this CD-ROM drive on your computer. Now this is the one that handles the CD. Now in the same way, your hard disk that is there inside your disk. Now today, in today's world, you can even get the external hard disk. Okay, there is this disk drive. So one electronic box, you will get it. Now how to interact with those things? How do I store that information in the hard disk and the CD-ROM? They are very different. Now this is device is controlled by the device controller, like you have disk controller or tape controller. So the when you interact with a particular system or a particular device, you must know how to interact with it. So it is not, if you are storing it in a tape, it's going to be continuous, whereas if it is a disk, it is something else. Now these are all complications that are involved when you want to store and retrieve the data from a physical media. Now these are all, but till today you have used it. Maybe you have used your pen drive, you have used your SD card, you might have used your hard disk. You never bother to look at how it is actually getting stored. Okay, so there is these devices have their own unique characteristics. Okay, some of the devices can be handled sequentially, and the other devices you can access randomly. So this is all handled by the operating system. Okay, so when we look at the data that we want to store in any of the devices, what the operating system will do is, operating system is going to tell you that don't worry about the devices, don't worry about how the complications that are involved in it. Okay, I am going to give you a uniform view, simple view. When you say it is a file, that's all. This is what you are supposed to know: how it is stored, where it is stored, how it is retrieved, and all these things you don't bother about it. You just know something called as a file, that's it. It's my file and I'm going to store it in pen drive. So operating system is going to provide you a uniform logical view of the information. It's going to abstract out all the physical properties. If you are storing it in your disk, how the things has to be stored. If you are storing it in a magnetic tape, how the things has to, all these things are abstracted out. Okay, and how to interact with them, these are all are being taken care of it. So what the operating system will do is, it's going to give you a logical unit called as a file. So it says that, okay, you want to store some information. That information can be simple as your text or your image or your video, your audio, anything for that matter. So what the operating system will tell you is, okay, everything is a file. Okay, it's a logical unit, and you just bother about the file. You just tell me, when you say I want to store that information, whether it is a picture, whether it's audio and something, you store it in the form of a file and give a name to that file. And tomorrow if you want that information, you tell me the name of that file, I'm going to retrieve it. So whether it is stored in your disk or whether it is stored in your pen drive, you don't bother about it. You have the device, you tell me where is the device, What type of device, you don't bother about it, whether it is a magnetic device, optical device, or some other type of device. Don't bother about it. You just tell me what is the name of the file, on which device it is there. I'm going to retrieve and give it to you. So if you want to store some information in any of the device, you tell me where is the device and give a name to that logical component. I'm going to store that and I'm going to get it back to you. So mapping of these files into the devices are also taken care by the operating system. So we have to know the definition of a file. So what is a file? This is generally something that you must know. So what is a file? File is a collection of related information. It's a collection of related information. For example, if I store my photograph, then it is my photograph, something related information that I've stored. I am recording my video now. This is again a related information. So as a creator, something that is logically connected. So collection of some related information which is defined by the creator. Remember, operating system, for the operating system, it is just the data that you are storing. Okay, it will not say that it is your image, it is your video, this is your audio. No, some related information. For example, if you are storing a audio file, then that is a related one song you are storing, related information. For the creator, it is one song. For the operating system, it may be song, it may be a file, it may be text, it may be a video, it may be anything. Operating system does not bother about it. Okay, so files can be either the program, as because you are most of you are you want to write programs, so you can write the program, that is set of instruction, or it could be data. So data could be like numbers, letters, or something. You know very well what is the data, so it is simple as that. Okay, when I say that it is a file, remember file, remember again, a very important thing over here is this logically related information is defined by the creator. So the creator will say how the information has to be stored, whether it has to be stored continuously, whether it has to be stored one line after the other, or whether it has to be stored in the form of a record with the register number, name, subject, marks in subject 1, marks in subject 2, and so on and so forth. All these are defined by the creator. Now when we look at the files may be a free form like a text files, continuously text are being stored, or maybe there may be a rigid format like if you look at the database, there is a rigid format like you have the register number must be 10, width of 10 characters, or width of a number with the specific width or specific decimal places and so on. There is a rigidity, whereas if you look at the text files, it is you can write it in any way you want to store it. Okay, again files could be bits, zeros and ones, or bytes, or maybe lines of text, or maybe records. Like you are using database, it could be a records. Now this is defined by the user. So now let's come back to the operating system. So what is this operating system will do? Operating system will implement an abstract concept called as a file, and it manages the data in a different storage media in the form of files. Okay, now if it is just one operating system just maintains the file, it stores information in the form of a file, and then it becomes very difficult to manage those files. So just assume that you are storing your files, your friend is storing files, their friends are storing files, everything is stored in one place, then it becomes very difficult to search for them and use it. So generally what is done is these files are neatly arranged in directories. So we logically separate one set of files from the other set of files. Like your files, you store it one. So you know very well, if you look at your hard disk, there is a folder called as movies. Inside movies you have Hindi, and inside movies you have Kannada, inside maybe Tamil, and so on and so forth. in that you have different movies, so you have logically arranged them so that it is easier for you to look at them and retrieve it back. Okay, so the next one that the operating system has to do is I create a file and I store it in the hard disk or a tape drive, whether somebody else can access this file or not. So should I allow the others to access or not? In other words, I have to have a control, and who is going to access this particular file, who is going to provide that control. That control is again provided by the file management system. So now let's look at what are the things that the operating system will do in terms of file management. So in terms of file management, operating system is responsible for creating the file, deleting the file. So you can create a file, you can delete the file, create a directory or delete the directory, you can read and write from the files, you can move the files, so you can rename the name that you have given to the file, that is primitives for manipulating the files, and you can map the files into the secondary storage, you can store them in the secondary storage device, and if at all you want, you can even back up into a different place so that you can use it in terms of some kind of catastrophic event, like your hard disk fails or something happens, so you can retrieve it from the backup. The next component that the operating system provides is the input output management. So when we look at any input output device for that matter, whether it is your keyboard, mouse, or your monitor or anything, all of them are complicated, and there is a specific way in which you have to interact with them. Okay, you only realize it when the things are not working. So when you don't get the output, when your monitor becomes blank, then you will realize that there is some complication. When you move the mouse, if the mouse pointer is not moving, then you realize that there is complication involved in that particular electronic gadget that you are using. So every input device or output device, there is a specific hardware that are associated with those devices, and the operating system must communicate with those hardwares. Okay, it is not magic that you are able to see the output on your screen. The operating system must know what is the length of the screen, how much wide it is, or how much resolution it has to show, whether it has to show it in color, black and white, or if you are giving it to the printer, how the printer is working. All these complications are handled by the input output management. Okay, so what are the things that the input output subsystem is responsible for? Managing the memory, that's very important. So what is the meaning of saying managing memory? Some of the devices are working very fast, other devices are working very slow. Now when I say very fast, very slow, what do I mean by saying that? In terms of your microprocessor, you know very well, your CPU or the microprocessor works at extremely terribly high speed. Your keyboard or your printer or any your mouse cannot compete with the speed of the microprocessor. For microprocessor, everything, every device that you are connected, they are very slow. So very slow devices for it. So if you just tell the microprocessor that I am going to type some name, my name, microprocessor will say you are taking too much of a time, I can execute gigahertz. That means giga instruction 10 to the power 9 instruction in a second I can do it, but you are taking 1 second to type a single letter. This is terribly, remember 10 to the power 9 is millions of instruction I can execute at a time. So this is what the CPU is going to say. I can execute millions of instruction at a time, but you are giving one instruction per second. This is very slow. It is like you are trying to compete with the aeroplane. So aeroplane will go at very fast, and you are going to say I am going to run like and compete with the aeroplane. You will not be able to even catch the aeroplane. You forget about the aeroplane, will go out of sight after some time. This is what happens when you type using your keyboard. It is terribly slow. So what the CPU has to do. Now, if you want to print something on the printer, if you compare the speed of the CPU, printer is terribly, very slow. So in that case, what to do? The CPU will say that I cannot give the instruction at this slow speed. It's not possible for me. So in that case, what you will generally do is you will buffer the content in the memory. So whatever that you are typing slowly and slowly, that is buffered, it is placed in the RAM initially, and once everything is done, you just ask the CPU, okay, the data is there in the RAM is slightly faster than my keyboard typing, so it is my typing speed is terribly slow, but I have typed everything and kept it in the RAM. Your speed is very fast, so you just go and take it from the RAM, so that you will go at your speed. So where do you place that? So you place it in the buffer. So where the buffer must be there, what must be the size of the buffer, who is going to handle? Input output subsystem. Sometimes we cache the data. Caching is if you are using the data repeatedly, you can use it. Other one is for the printer. We usually do something called as spooling. Spooling is writing everything into a disk and then slowly reading the disk file and then giving it to the printer. The next one is how do we interact with the various devices. Now today, you know very well, there are hundreds and thousands of devices are there. We have Bluetooth audio system. How do you interact with your audio system? You can connect your phone with the computer, you can connect your wristwatch with the computer, you can connect microwave oven with your computer, you can connect your fan with the, and so on and so forth. How do you interact, how does the computer interact with the various devices? Remember, there is something called as device drivers. They are specific software that helps the operating system to interact with the devices. There are generally two categories of devices, device drivers. One is general purpose devices, and the other one is specific hardware devices. Now, some of you might have realized that thing. So you are getting the output on your screen, and everything looks fine. But when you go to college and when you connect your laptop to the projector, nothing comes in the projector, and people just panic. Why it is not coming? Is the projector is not working? Projector is working fine. The problem is you are not using a specific display drivers. So you are using Microsoft, if you use Windows, Microsoft default device drivers. So Microsoft default drivers will only drive your monitor, that is your display, or on the laptop. It will not drive any content to the your LCD projector or any other projectors. So that's why you are not able to get it. So if you take it to the hardware technician or maybe your computer technician, they will say that the driver has to be installed, and they will install the driver for you. So that is called as specific drivers for that matter. Okay, all these things are taken care by the input output system of the, when I say all these things, it doesn't mean that you are taking it to the hardware person. No, the drivers, which device, which driver has to be used, and how to interact with the device, when to send the data, when to receive the data, how to send the data, how to receive the data, how to send the control information. What do I mean by saying control information is when you are printing on your printer, the page gets ejected, so there is no more page. In that case, the printer will give an error message saying that there is no more page in the printer. You don't give any print now, or the page got stuck. So don't give any print. So this is control information. That information has to be taken by the operating system, and some error message has to be shown on the screen so that the user knows that something went wrong with the printer. Now, how do you send the control information? How do you tell the printer to stop printing and eject the page? This is control information. How to send it? Who is going to take care? That is taken care by the input output system. Now let's look at one other component, and that is the secondary storage management system. And we know very well, if you compare your primary storage, that is RAM, with your secondary storage, that is your hard disk. Your hard disk is 1 tera, and your RAM, maybe if you are lucky enough, it is 16 GB or 8 GB or 4 GB. There is no comparison between your RAM and hard disk. Hard disk is 1024 GB, whereas your RAM is 4 GB. Where is the 1020 comparison? There is no comparison at all. So RAM is very small in comparison with the hard disk that you have, that is the secondary storage that you have. There is the other problem with the RAM, and you know very well, if you switch off the machine or if the power goes off, whatever that is there, whatever data that is there in the, or whatever instruction which is there in the RAM, you are going to lose it. So you're going to lose the entire data when the power fails. Okay. Now, in that case, what to do? In that case, you have to back up the content which is there in the memory. Now, I told you that you can run more than one program at a time on a CPU, on a computer. The reason why you want more than one program is to increase the efficiency, so that the CPU is always put into action. Now, there is a less RAM here. How do you go about doing it? You usually take the backup. So secondary storage is used as a backup memory. So your programs are there, like your compilers may be there, assemblers may be there, your Microsoft Word, Excel, whatever, everything is stored in your hard disk. As and when it is required, it is loaded into the RAM. So from the hard disk, you load it to the, so you have your disk here. So you have the disk. So disk contains your Microsoft Word. When it is required, you load that Microsoft Word into the RAM. And when you create a file in the Microsoft Word, that file, when you save it, it will be again saved. It is not just Microsoft. In the Microsoft Word, you will type something. You will create a file. That file has to be stored. Now, where do you store that? Again, back into the secondary storage device. So what the operating system will do it, operating system must make a proper management of the disk storage. So what are the things the operating system will do? So if you have a hard disk, I'm just showing a disk structure, don't get confused with that. So don't just say that there is one disk. I think all of you have studied about the hard disk. Now in the hard disk, you have tracks and sectors. Now which track has the data, which track does not have the data? So that is called as a free space management. Where are the free spaces in the hard disk? Do you have the free space here? Whether do you have this free space here? Whether it is continuous, whether it is discontinuous. So all these things are taken care by the secondary storage management system. When you store a new file into the disk, whether it has to be stored here, whether it has to be stored here, whether it has to be stored somewhere else, who is going to take care? That is storage allocation. Who is going to take care? That is the secondary storage management. Also, if more than one request comes for the disk access, so you are playing a video and you are saving. So saving is also done. You want to save the file, at the same time you are playing a video, so some data has to be read, or maybe something else is getting printed, and so on and so forth. So more than one request comes. In that case, it has to be scheduled. Which request has to be first done, which has to go next, and so on and so forth. Who is going to take care? That is again taken care by the secondary storage management system. The next thing that the operating system provides is networking. So what is networking? So networking allows us to share the resources, as well as networking allows us to access the resources which are shared on a physically separate machine, which may be running on the same operating system, or which may be running a different operating system, which may be a computer, which may be that the device can be mobile, that device can be your fan, that device can be your car, that device could be anything. Okay, so it may be a heterogeneous system, okay, but you are accessing it in a single coherent way. Okay, so networking allows us to share the resources. When you share the resources, what are the advantage of sharing the resources? You can speed up the information. So if you are doing something on your computer, you can share it with the others, so that others can also simultaneously work on the same data, and then they can increase the processing. Also, you get increased functionality. For example, I don't have a printer connected to my machine, but my friend has a printer. I can connect to via networking. I can connect my computer to my friend's computer and then share that resources. So I am increasing my functionality. Okay, also the data availability, and today you know very well that's a very important thing. The data is should be available everywhere. The next one is the reliability. So you store it on the network, it is reliable. If my machine fails, yeah, I can access it from the other machine. So reliable. So that comes over here. Okay, generally whenever we look at the networking, we generally look at the networking in the form of a file access. We store the file and we retrieve the file. That is what we generally think. So network means you are storing a file at a remote location and getting it back. That's definitely one use, but networking has many other use. Okay, so how do I send the data and how do I make the request? All these things are taken care by something called as a network interface device driver. So there is a driver that drives that networking hardware, and who is going to interact with it? That is the operating system. Also, in order for us to communicate from one system to the other system, there must be a set of rules that need to be followed, and this set of rules are generally called as protocols. So you know very well, if you are driving on the road, you have to be driving on one side of the road, not on the middle of the road. One side you have to drive it. So that is the protocol, you are supposed to follow it. In the same way, if you want to connect your computer to the other computer, how to send the request, how long has to you have to wait until you get the response, all these are called as protocols, and you have to follow the protocol. There are different types of protocols which are available for different purposes. Okay, I will not go in depth into that. Let's look at the other functionality or other component that the operating system has, and that is the protection system. Now, very important thing, when you have more than one person accessing your system, there must be a some way of protection that is required. So what is the meaning of saying a protection? Protection is a mechanism for controlling the access. So it is a way in which you impose certain restrictions on something. What are these something? On the program or the processor or the user, so that they are allowed to access some resources, they are not allowed to access the resources, or they are allowed to access the resources only in a specified format. Okay, so some kind of control or some kind of restrictions are imposed, and this is what is taken care by the protection system. Protection is very important when there are multiple users who are executing their program concurrently. So what I am doing, I don't want somebody else to destroy whatever files I have created, or I don't want my programs to disturb the others program. So there must be a way in which my files are protected, my memory that I am accessing, the RAM that I am accessing, that is protected, my instructions are not being manipulated. Who is going to take care of them is the operating system's protection system. How do we take care of it? By the form of authorization. So operating system provides a proper authorization. So only authorized person can read the content from the file. Authorized person can write into a file, and so on and so forth. So this is how the protection is applied. So what's the advantage when you have the protection system? Protection system can improve the reliability. We can rely on the operating system and say that okay, my files are safe, they are not going to be destroyed because my operating system is powerful enough. Okay, also it can detect some hidden errors that may come in the interface. Okay, so that you can prevent the contamination of this system by somebody else. Today we have something called viruses and so on and so forth that can contaminate the system. If your operating system is powerful enough, it will prevent unauthorized access to the content. The next and a very important part of a component of any operating system is the command interpreter. Now, how do I interact with the operating system? That's very important. So, you know very well there are a lot of components are there in the operating system. As a user, how do I interact with it? If I run my program, how my program will interact with the operating system. So you have written a program to sort the numbers. How does it interacts with the operating system? So there must be an interface. Interface is something that your program or you use to interact with the operating system. Okay, when you look at the operating system generally has something called as a command interface or command interpreter. So whichever command that you give, it interprets and then takes the action. Now in some of the system, the command interpreters are part of the kernel. As I've already told you, kernel is the core of the operating system. So interpreter is generally part of that code generally. Okay, but in most of the system, the interpreter, that command interpreter, is a special program usually called as a shell that is started when you log on to the system or when the computer or the operating system starts. So what's the advantage of putting the command interpreter outside the kernel is if it is a part of the kernel, you can't change that interpreter. Whereas if it is a separate special program, you can at any time change it and put some other shell. That is why in Unix, you have a lot of shells in Unix. So for a different purpose, we have different shells. That is a good thing. That is a good way. And if you are using Linux, for that matter, there are different desktops are available. So every desktop has a different way of showing the buttons, showing the text box and so on and so forth, the window and the taskbar and so on and so forth. So interface can be changed because it is not part of the kernel. That is an advantage there. Now let's look at the command interpreter. Okay, whenever we want to interact with the operating system, we give some control statement. So we tell the operating system, you do this, you save my file, you retry my file. Some control informations are given. There is a program, so one program that reads our instructions or our control statement, interprets it, and then takes action. This particular program is called as control card interpreter. So this is called as control card interpreter. Also, it is also called as command line interpreter, or it is commonly called as a shell. So shell is a special program that interprets your commands. Okay, first of all it reads the command that you have typed, interprets it. If it can understand whatever commands you have given, then it carries out that command. Okay, there are generally two types of commands interpreters which are there. One is the command line shell. So that means you type the commands in the form of a text. You type the command and it's going to take action. Other one is the GUI based interface, wherein you use the mouse to click on the buttons, the menus, and there is a window. You know very well, you are using Microsoft Windows or maybe Android. You have all these beautiful buttons and so on and so forth. You can touch them or you can click them to interact with them. You don't need to type the command. So these are all the components which are part of the operating system. If you want to learn more about it, please refer to the Galvin's operating system concept book, which is available in most of the libraries. Thank you for your interest.